Hey everybody, welcome to your first notes video for geometry. I'm just here to say hello to you, give you a little overview of what I have on my screen right now. So we're a little unique today because we haven't gotten any physical papers in your hands. Again, I told you you're going to get a packet of all of our notes for the unit with the classworks. But if the need arises that you don't have that available to you or you maybe forgot it somewhere, um, or again, if we switch your remote and I didn't have a chance to get it to you before we left, this is my way of kind of modeling for you what you can be doing. Now, I'm using a digital version over here on the right hand side of my screen. Imagine this is actually a notebook or a piece of paper you could put in your binders. I really would love you to be handwriting things out. I feel that you just watching something on the TV is passive. Your brain doesn't really absorb it. So seeing it and writing it physically with your hand is always a better option for you to learn better. And that's a good skill across the board, especially when you might go into a college level class or another class that you have just strictly do online and you want to take something out of it. So, looking here, this, if you do have the option to print out the assignment I attached into Classroom, you would see this on your desk and you can handwrite it in as we go. But what I want you doing and what I kind of modeled for us here is I took all the information on this sheet and I put it over here. Okay. So I kind of just listed out the keywords angle. I wrote that down and kind of boxed it in so I can write something next to it, left some space. Vertex, I saw this picture, so I hand wrote it out. So if you want to pause our video right now, actually do that on paper, and I'll scroll here for you. Um, through this assignment, I wrote down the key facts from the PDF file you see here. So acute angle, right angle, obtuse angle, straight angle, reflex angle. Um, so again, with the fill in the blanks, it makes it really easy, but we're going to draw a lot of pictures over here. You can kind of see my pen. Let me undo that though, because it doesn't look so pretty. So I'll get those writings off of there. So anything I'm digitally handwriting on my screen right now is what you would be physically writing into a notebook. So again, imagine this is a piece of paper in front of you and not a digital assignment like I have. Other things I put were, sorry, I'm trying to scroll it and talk at the same time. Here, I'm going to get myself out of here. So we'll see you at the end. I'll come back. So looking through our notes, we had some more words down at the bottom of our notes page. Okay. And then we have some exercises that we're going to do together, some examples. So exercise 1, I kind of went to a separate page here to look at and left space to be working on those examples here. So if you have a couple pieces of paper, we're going to need them. So starting with the notes for today. So I'm going to use what I hand wrote out here, if that simplifies for most of us. But let's get started. An angle. An angle is formed by two rays. So looking at this diagram here, there's a middle piece. An array, remember, is a line that only extends in one direction. So an angle is formed by two, what's called a ray. Okay. And those two rays meet at the vertex. So the vertex is a point where the rays meet. Okay. So if we were to name this, we have ray BA, if you remember this notation from middle school, and ray BC. And those form an opening. Okay. This opening we can classify as acute, right, obtuse, or straight. So looking at that angle measures a little bit less than 90 degrees. So that's considered an acute angle. So an acute angle measures less than 90 degrees, right? So the angle would be small and cute. This angle here, I forgot about naming an angle. So how we name an angle, which I could tell was something a couple of us struggled with on our classwork 1.00 you did on Wednesday for me, is that this angle has 3 letters, all right? So we can name it a couple different ways. We can call this angle, and I'm going to start at a ray, go to the vertex, and go down here. So we can call that angle, so that's a symbol for angle, A, B, C. Or if we start down at C and go kind of counterclockwise around that picture, we could call that angle CBA. But notice that vertex, again, the vocab word over here, vertex, is a letter in the middle. Something else I like to do when we get bigger diagrams is put a little fancy number in there, like angle 1, and I refer to that as angle 1. So I kind of name it with a number. That's not its degree measure, but I would say angle 1 is equal to, let's say, 70 degrees, okay? Because we know a right angle, and this is actually the next vocab word, measures 90 degrees. So if a line goes straight up north, okay, and then to the right east, right? If we're thinking of northeast, southwest, that makes a 90-degree angle. So we know that a right angle measures 90 degrees. Sorry about my handwriting on the screen. I'm still getting used to the digital aspect here. But it measures 90 degrees. Okay. So a little notation is if we have one line going one way, one line going the other, we put this little box in there. That box always means 90 degrees. Another symbol we see sometimes with 90-degree angles is an upside down T. I don't know if you guys remember that symbol, but we might say line AB is perpendicular to line BC. So this upside down T symbol here means the word perpendicular. Perpendicular. Right. And again, apologies with the handwriting here, but the words that are in black, the big words, those are already written somewhere. And I hope as I'm talking, if you need to pause and rewind to hear what I say, you can have that opportunity. But to kind of keep things flowing, an obtuse angle. So acute, right, and obtuse kind of go in order. Acute is an angle less than 90 degrees. Right is an angle that's equal to 90 degrees. And an obtuse angle measures more than 90 degrees. But an obtuse angle is not going to be less than 180. So if I draw a straight line left to right here, okay, that, if we kind of put a little dot in the middle and name it A, B, C, okay, that actually is our next word, a straight angle. But if I start at B and I kind of draw a ray from there, I'm going to call it BD. What I've done is I've taken this straight angle and broken it into 2 angles. They are called supplementary angles. So that's another vocab word we're going to do in a minute. But those 2 supplementary angles add to 180. So this smaller angle open to the left is, let's say, 60 degrees. Okay. This larger angle has to add to 180, 180 degrees. So if we're thinking about a circle, like you guys know, some X Games athletes do 360s, 720s when they're spinning on a bike or doing a snowboard trick, okay? So think about 180 degrees. If you're standing somewhere, okay, and you spin all the way around, you've gone 360 degrees. If you only spin halfway around, okay, you've gone half of 360 is 180. So that's kind of where our 180 degrees comes in. We're going to have other degree measures with our circles way later this year. But again, a straight angle. So I do see a mistake I just made here. If anybody had to pause your video and find out, that angle from here to here, again, is 120, where both of these add to 180. So again, my mistake with that one. Um, a straight angle is just an angle that extends all the way to the left, all the way to the right, or all the way up north and all the way down south. Okay. A reflex angle is kind of a special case. We really won't use it all that much, but I didn't want to leave it out because it might show up in one of the multiple choice answers along the way. A reflex angle is an angle measuring between 180 degrees is less than x is less than 360. So that measure of the angle is somewhere between 180 and 360. So it's actually greater than 180. And how that works is if I have a point and I'm going straight over, okay, and we are walking along this point and we see this angle open, okay, this would be its 180 mark, but we're going to dip down below that, okay, and that angle all the way around. So not all the way 360 around, but more than 180 around. So maybe let's say that arc mark is more than 180, but not quite here. 270 would be down here if you're thinking about a clock. Let's say that's 210 degrees. Okay. So more than 180. Again, that's a degree symbol. So something I've done to some of these is put this little circle up atop. Again, that just denotes how many degrees. So straight angles, I did skip over writing down, is 180 degrees. So acute angles, just to go back over, are less than 90. Right angles, another word for right might be perpendicular, you might see, equal exactly 90 and have this little box in them. Obtuse angles are any angle bigger than 90 degrees but smaller than 180. Straight angles always equal 180. And we have reflex angles. Okay, so those are some of the simpler vocabulary. Once these next set of words is when you put two angles together and they have some sort of sum, they add together to something. So adjacent angles are angles that share a side. And again, you know, math is a lot of symbols. So again, every time I do this sideways V with a little arc in it, that's the word angle. I usually remember to say that at the beginning, but I probably skipped that for some of us. Um, so two angles that share a side. If I draw an obtuse angle, and then from the vertex in the middle, I kind of split that angle into two other pieces, okay, that those two angles are adjacent angles. So if I name the little one angle 1 and the big one angle 2, we would say that angle 1 and angle 2 are adjacent, ADJ. Okay. So they just share a side. They don't add up to 90 or 180. Okay. They aren't equal to each other, or congruent is another fancy word that showed up on your classwork the other day. All right. So again, the word congruent, I'm going to come back to in a few minutes. Okay. Under vertical angles. They're just two angles that share a side. So adjacent angles can be complementary, and they also we could describe them as supplementary. So adjacent, complementary, and supplementary are kind of all related. But more specific, adjacent angles that add to 90 degrees are angles that are complementary. So if I have a right angle, like let's think about a wall, okay? Here's a wall coming down, and here's the floor coming out. There's a right angle. If I were to like take a pole and put it in the corner at some sort of uh, angle, I hate to be keeping using the word angle, that's going to split this angle into two pieces. Now, I could break that into a 45-degree and 45-degree angle where they're both equal to each other, 45 and 45, but those two angles will always add to 90. So if I moved that piece, if I kind of moved it down here this way, I wouldn't have a 45-45 split anymore. Okay, so I'm going to do is I'm going to erase that first one. I made this little angle at the bottom smaller and the other angle larger. So then this smaller angle, let's get a different color here. The smaller angle might be 30 degrees, making this angle 60 degrees because 30 plus 60 is 90. Now, a little way to remember complementary versus supplementary. The C, complement. I thought I could use that pen. I guess I can't. The C in complementary here can be made into a big 9. Okay, so that helps me remember 90 degrees. Now, a word like complementary is this next one below it, supplementary. So supplementary angle pairs are two adjacent angles. Again, we started over here at adjacent. They're adjacent angles that add to 180 degrees. So drawing a diagram for that, because again, everything has some words and a picture to go along with it. That's a picture we had before. So I drew a straight line, okay, point in the middle, and had this ray coming out from here. Okay, you guys might remember seeing a protractor. Yeah, let me bring up a picture of a protractor just to remind you. A protractor is this fancy angle measuring tool you might have used in middle school at some point. Yeah? Okay. So you remember reading the outside numbers or the inside numbers? Well, each set of numbers always adds to 180. 80 and 100 adds to 180, 7 and 110. All right. So those protractors measure these straight lines, the supplementary angle pairs. So if this major angle, this obtuse angle here is 135 degrees, then this acute angle here would be its supplement. So if we take 180 minus 135, we should get 45 degrees. So be careful with your mental math there. Sometimes you might need to bring up your fancy dancy graphing calculators. Okay. So again, if you have that Chromebook, it should be up in your launcher somewhere. The rest of you should check our classroom. I did put a link for a graphing calculator in there. So 180 minus the 135 does give us, let's try that again, Miss Locke. 180 minus 135 gives you 45 degrees. So that is indeed supplementary. Okay. Vertical angles. Okay. Vertical angles form, let's write it like this. Let's say vertical angles are congruent. And what congruent means is it means that they're equal in measure. So again, each year you kind of go through math, you learn fancier words that mean something really simple, right? So the word congruent just means equal. So if I draw you two lines, so this line kind of extends northwest to southeast, and another line that kind of crisscrosses and makes the X here. The vertical angles are the angles opposite each other that are equal in measure. So, one of the pictures from your classwork yesterday named these four angles here 1, 2, 3, 4. So, when I had these two straight lines coming through, I had four different angle measures there. So, angles 1 and 3 are equal, as well as 2 and 4. So we can say angle 1 is congruent to angle 3. So this is a new fancy symbol for us, and I'm going to come back to it later. But it's like a squiggle sign with an equals, meaning congruent, right? But those measures are equal. So maybe they are 70 degrees here and 70 degrees over there. So whatever one measure is, the other measure will be equal. Okay. For the most part, those are all the vocabulary words that we'll need. Okay. So that kind of ends our vocabulary section. One other thing I just noticed in our notes that I'm going to circle back to because it comes up. Another word for supplementary angles is called a linear pair. So a linear pair is two angles that make a full line, right? So 45 and 135 will always add to 180. One other thing, I gave you a little hint that complementary, that C in complementary made a 9. Guess what this S does? It can kind of make you an 8 to help you remember 180. All right. So if that helps you decipher between complementary versus supplementary, that's what I got there. Okay. Moving forward, I'm looking at exercise 1. So looking at exercise 1 at the bottom of your notes page, angles 1 and 2 are complementary. Right. So again, we know complementary adds to 90. If angle 1 is 63, then the measure of 2 is going to be what? So if I drew a picture with you for that, complementary, again, we know two angles make 90 degrees. So I'm going to draw our picture there. I'm going to have a ray come out. The larger of the two angles is going to be 63 degrees. And when we take 90, subtract 63, we get 27 degrees. Okay. So that's the work shown that I'm going to be looking for in your classwork. So what I'm doing on the second page is what I'd like you to be doing in order to work through the classwork. Okay. Now I'm going to do like 3 examples here with you and then kind of talk through what I'd like you to be doing for your classwork assignment. But for now, if you have a sheet of paper and you're writing down exercise 1, you're drawing a diagram and showing a little bit of math on how you got your answer, that's going to help me correct whatever mistakes you could be making in the future and kind of get us all on the same direction moving forward. So that's exercise 1. If I move to exercise 2, it reads, each type of angle is shown below. Judging by the sight alone, so kind of making an assumption here, classify each one as acute, obtuse, right, straight, or reflex. Okay, so it looks like there's 5 diagrams. So I'm just going to kind of start writing those words almost in those positions. So if I'm over on my notes page, I have 1, 2, 3, 4, 5. If you'd like to draw the pictures with them, you can. But looking at that first picture, that angle appears more than 90 degrees. So that's going to be obtuse. Okay. And this is where having 2 sheets of paper, your notes on one piece of paper already handwritten out for you is going to help, especially when you come to a quiz or a test in a couple weeks. In class quizzes, you can be using your handwritten notes for. So again, we have open notebook quizzes. So I strongly, strongly, strongly encourage you to be handwriting everything out. Make it neat so you can read it later when you need it. The second picture here looks to be a pretty big angle. Okay, if that extended over about there, you can see where my little cursor is, that's going to be the reflex angle. RE, flex. Okay. The third one is acute baby angle, kind of opening down. That's going to be an acute angle. ACUTE. My handwriting is not so great on that. I'm sorry. Acute. And it helps if it picks the pen back up. Sorry about that. The next one is going to be a straight. That looks pretty much like a straight line to me. So I'm going to assume it to be a straight angle. And the last one looks pretty much like a corner. So I'm going to say that that's the right angle. Moving down to exercise 3. Given WRX, so that's like some new notation for us. WRX, what they're telling you there is that's a straight line. All 3 letters are in one line with that line symbol above it. Solve for the value X and the numerical values of measure of angle VRY and the measure of angle WRV. So this being a straight angle for exercise 3 here, so we have the straight angle and the ray coming out. I'm going to minimize. We have this side being 3x plus 22. Again, sorry about the handwriting. Let's see if I use a different something. There we go. 3x plus 22. And the other one is 2x minus 12. Again, I think I'm delaying as I'm trying to write here. But those two things make a straight line of 180 degrees. So we're going to set up an equation. 2x minus 12 plus its next angle, 3x plus 22 equals 180. And this is where our algebra comes in. Combine like terms, we get 5x, negative 12 added to 22. Well, negative 12 plus 22, let's do it this way. Negative 12 plus 22 gives us 10. Okay, so 5x plus 10 equals 180. Subtract your 10 over. 5x equals 170. Again, if I'm going too fast, you can rewind and come back to it. Divide by 5 and x is 34. So with this geometry course, once you find x, that's the algebra level. We've moved up a year into geometry. We're in 10th grade now. We don't just stop at x. Our value of x is not our final answer here. We have to come back to our picture. And the silly picture at that, Miss Luck has a lot of writing all over. But each of these angles are twice x minus 12. So we're going to take our x value of 34, and the two angles are going to be 2 times 34 minus 12. So in the calculator, 2 times 34 minus 12 should give us 56 degrees. And our other angle, 3x plus 22, 3 times the 34, which is the x value, add 22, we should get a supplement, 124. So those two angles are what they were asking for. The measure of VRX, let's hide the calculator, VRX here, and the measure of WRV. So again, labeling your picture, putting those in. Again, this says a 1, 2, 4. It's just the way my pen kind of scooches across the screen. So hopefully you have a little bit better luck with actual pen and paper. Number 4, again, in that diagram for number 4, we see this little right angle symbol. I'm going to jump over here. Okay. Let's close that for a second. Here we see a right angle symbol. So if I just look at the examples on the page, here they tell me that angle PMQ is 42. Now this is where we really have to practice tracing. So PMQ is 42 degrees. Find the measure of angle NMP. NMP, if you trace, again, I'm going from N to M to P, appears to be that complement. So 90 subtract 42 should give us 48 degrees. Now I'm going to skip part B for timing. And the last case, number 5, is the diagram. So here's our big X, right? We have one line coming down this way and one line coming up this way. Where else did we see that, right? This is where you have to take a peek at your notes page. So if I scroll back up in my notes, I saw that picture right over here at vertical angles. So if that helps you as you're doing these questions, please go back and forth with what you can. So let's see, there, it pulls it back up for me. So vertical angles are equal. So seeing that 103 there tells me that angle 103 down here and this angle up top are going to be equal. But another little piece, if I kind of erase a little bit, I guess my eraser didn't pick up. Sorry about that. We have a straight line. So angle X there and angle Y here are making a straight line. So they're supplementary, or they form a linear pair. So I'm going to write the word sup or linear pair. It's the letter I there, by the way. So if we take 180, subtract the 103, we're left with 77 degrees. Okay, so that's the notes with a couple examples done for you. Moving through the rest of what's here, the classwork I'm asking you to do, right? If you could, on scrap paper, again, if you just want to number your scrap paper and put the answers next to the numbers, that's fine with me. But here we have different angle pairs. Now, some of these answers, I will say you might use some of these answers more than once. There's a couple different ways to name these. Number 2, a lot of people usually get a little confused about. Those are adjacent. Okay, A is obtuse, B is acute, but those two angles as a pair is what we're looking at, are adjacent angles. So I'll tell you the answer here for number 2. I do know students kind of get confused with A and B are adjacent to each other. Okay, same thing with number 3. We're just going to call those adjacent. They make an obtuse angle together, A and B, and number 2. These two make an acute angle together, but we really want to focus on how they are related to one another. So that was 1 through 6. My numbering is a bit off here, right? Because there's another 1, 2, and 3 again. But here, I'd like you to name the type of angle. So if I do this number 1 with you, these angles, they form that X again. So I want you to use some vocabulary, are vertical angles. Okay. And they are equal in measure. So here, X would be 55 degrees. Same case with number 2. Those are also vertical, but we need to find the value of X. So knowing that they're equal, here, think about it as X equals 55. For number 2, the angle represented by something minus 5 equals 42. So you can solve for x as like a little equation there. Right? 3 should be pretty self-explanatory. Moving to the back page. Remember for number 4, all the way around a circle makes 360 degrees. So you have a reflex angle of 209, an obtuse angle of 96, and you're trying to find the missing piece in the middle there, B. Sorry, I keep trying to scroll the page and not pick up the mouse. Last but not least, number 5. Those two angles are vertical angles. You're going to set them equal, if that's a little clue. And remember, a little vocab here for 6 and 7 is that linear pair is the same as supplementary. They're going to add to 180 degrees. Okay, so you just have to find the value of x. A drawing for number 7 could be a straight line with a little ray coming from it. And you kind of number each of those, or name, I should say, each of those little angles, angle 1 and angle 2. So angle 1 is represented by 7x plus 10. Angle 2 is represented by 3x. And since there's a linear pair, those angles would add to 180 degrees. So I hope that little clue helps. Good luck with the classwork. Again, please handwrite it out on paper and upload a picture so you get full credit for your class today. Have a great weekend. We'll hopefully see you guys Monday or Thursday, I guess, next week. Email me with any questions.